A very good morning to our lecturer, Dr. Ng. My name is Yong Jin and my metric number is 217086. This is our group project presentation video and I will start my individual presentation now. So, first of all, I will introduce the back end of our mobile project. The back end of our project is using Node.js and the MVC architecture, which is Model View Controller Architecture. There are a few different folders which are Model, Controller, and Root folder. So this is for the separation of concern. The model defines the data and the structure of the collection, which state the key and the type of the value. So the controller is the logic for the implementation when the specific request is made. The route would contain all the path for different requests. So the upper part of the code is the dependency of the module required, and the project will connect to the MongoDB as the database. We also use a WebSocket for fetching real-time data for the gauge data, which needs to be updated every second for the observation of value. We have 5 models, which are Engineer Factory, Factory Data, Factory Engineer, Registered, and Threshold. So, first of all, let us start with the Engineer Controller. So, this is the implementation of the Engineer Controller.js. So, this code defines an Express.js router and the controller for managing the engineer data within a factory context. So, the router includes the endpoints for sending notification, requesting OTP, registering engineers, and retrieving data for the registered phone number. So, the first function is Notify function. This function will send an SMS notification via Twilio to registered users. So, the request OTP function will generate and return a 6-digit OTP if the phone number is registered. So the registered engineer function will either update the factory list for an existing engineer or creates a new record if the engineer does not exist. So this also ensures if the engineer is registered in the database. So the get engineer function will retrieve and sort all the engineer by the factory number, while the get user factory function will fetch the factory associations for a given engineer phone number. So this setup will facilitate the efficient management of the engineer and factory data and leveraging the MongoDB models for data persistence and validation. Next, I would like to introduce the factory controller.js. So this code will define as the same also Express.js router and controller for managing the factory threshold settings and retrieving the gauge data. This router will include the endpoints for updating threshold settings, retrieving the current threshold settings, and fetching historical gauge data for a specific factory on a particular date and getting the gauge threshold setting for a factory. So the controller will handle all these requests by either updating or creating a new threshold settings in the threshold collection or retrieving the required data from the threshold and factory data collection. So the update threshold method will either update or create the threshold settings, while the get factory threshold will retrieve these settings for a specific factory number, and the get gauge factory data method will fetch historical gauge data for a factory within a specific date range. So finally, the get gauge threshold will retrieve the current threshold settings for a given factory. So these functionalities will ensure the efficient management and real-time monitoring of the factory parameters. So I would like to introduce the model side of the code. So all these files are the modules for a Node.js application that defines the Mongo's models for interacting with a MongoDB collection. All the models can be used to create, read, update, and delete documents in the corresponding MongoDB collection. So for engineerfactory.js, this file is created for storing information about engineers and their associated factories in a MongoDB collection. In registered.js, the purpose of this file is to create a schema and a model for storing registered phone number in a MongoDB database. For the routing, this script will provide a complete setup for a real-time web application that interacts with a MongoDB database and uses WebSocket for real-time data updates along with Twilio for SMS notification. In order to get the real-time data, our group has established a WebSocket connection with a client implemented in the app.js file. The server will then listen for the message from client and it is parsed to extract the factory number. Next, the fetch data and fetch threshold are also called to retrieve the necessary data and threshold. The data is then sent to the client at 1 second interval using set interval. When the client disconnects or if an error occurs, the interval will be cleared. I would like to introduce the client side, which is the front end of the code. So on the front end, the home widget is the stateful widget. In the home.dart, it accepts the factory number parameter to identify which factory data to be displayed. First of all, the init state is overridden to call the connect WebSocket and when the widget is first created. Connect WebSocket will establish a WebSocket connection to the backend server at ws.// 10.0.2.2.3000. Then it will send a message to the server with the factory number and prompt the server to begin sending data. So it listens for the incoming message from the WebSocket stream. After receiving the data, it decodes the JSON data and updates the state variable accordingly. Lastly, the set state is called to rebuild the widget with the latest factory data. I would like to introduce the front end, which is the client side of the code. In the home.dart, our home widget is a stateful widget, so it accepts a factory number parameter to identify which factory data to be displayed. So first, the init state is overridden to call the connect WebSocket when the widget is first created. So the connect WebSocket will establish a WebSocket connection to the backend server at ws//10.0.0.0.3000. So it will send a message to the server with the factory number and prompt the server to begin sending data. The WebSocket will listen for the incoming message from the WebSocket stream. So after receiving data, it will decode with the JSON data and update the state variables accordingly. Lastly, the set state is called to rebuild the widget with the latest factory data. So for update the threshold setting, we implemented in the home.dart. So in the function, we compare the real-time data with the preset threshold value. If the steam pressure is below the threshold, we will trigger the notification. Similarly, if the steam flow is below the threshold, another notification will appear, and it does the same for water level and power frequency. Each notification indicates that a reading has fallen outside the preset threshold, and if the factory number changes, it will reset the WebSocket connection. So the format value function will format a double value to 2 decimal places. So for displaying the graph, we have implemented in the API.dart. So within the service folder, the two methods are created to fetch data using the backend API. So the getGaugeFactoryData method will take the factory number and date as parameters and retrieve the data using http.get, mapping it to the factory data model. So the getGaugeThreshold method, it will require the factory number and includes it in the URI as a query parameter and fetch the threshold data, mapping it into the threshold data model. In graph.dart, the initialize data function is called within the initState method to retrieve the list of factory data and threshold from the backend by calling the getFactoryData function and the getGaugeThreshold function. The retrieved data is categorized into average, maximum, and minimum values for different parameters such as steam pressure, steam flow, water level, and power frequency using specific methods such as getAverageGaugeReading, getMaximumGaugeReading, and getMinimumGaugeReading. So the data is then stored in the overall gauge reading list. So now I would like to demonstrate the application for how it is working. So first of all, we will go to the backend side of the code, and in the terminal section, we will type the code node app. So the server is listening on port 3000 and it shows the message that we are connected to the database. So let us run the main.dart. Okay, so let us enter the mobile number to activate our account. First of all, let us test with a mobile number which is not registered. And if we press the get activation code, it will say that we didn't agree to the terms and conditions. So let us click the button and agree to the terms and conditions. And let us get the activation code again, and it will show that the phone number is not registered. So now we will try to use the phone number that is registered. So we will get the activation code, and the OTP shown is 829667. So if we insert the incorrect OTP, let us see what will happen. So it will show that incorrect OTP. So we will enter the correct OTP again. So let us activate the account, and the message will be shown OTP is correct. So first of all, we have created an endpoint to generate and send the OTP to the registered user phone number and validate the OTP in the API.dart. At the terminal side of the backend code, it will show that the phone number is not registered, and it generates the OTP for the phone number which is registered. So let us go back to the main.dart. Now we will try to add the engineer. By clicking on the add button, we will go to the invitation page and we can type the owner's name. Let us type Thomas, and the full number will be 01234567889. So let us click submit, and the newly added number is shown in the factory 2 engineer list. So this shows that the Thomas has been added to factory 2. Alright, so now we have shown that the new engineer is added to the factory 2. Now we will go to the dashboard for the value, and we can see that the value such as steam flow, power frequency, water level and steam pressure of factory 2 data is changed at 1 second interval. So every second it will display the data of factory 2. So for factory 3 it is also the same, and we will now see there is no notification that pop up. This is because there is no readings that fell outside the preset threshold. So if we click on the save button, we can see that the factory 3, it will trigger the notification that the steam pressure reading fell outside the preset threshold. So in order to stop the notification, we can go back to the setting and change the minimum threshold again. Now we set the steam pressure as to 30 bar and click on the save button, and we will see. And we can see that there is no notification triggered as the minimum threshold has been changed and the data has been sent to the database. So therefore, the notification will not be triggered. So now we can see the graph by clicking on the gauge of any widget. These four widgets can show the graph. So let us click on the first one, steam flow. And we can see that the calendar for this graph, it will show the exact date of the reading, which is 2nd of August. So for the labeling, the dark blue color is the maximum, and the yellow color line is average, the light blue is minimum, and the threshold is the red line. So we can double click to zoom in the graph in order to view the time interval at a more detailed mode. So we can go back to the dashboard again and click on the power frequency, and we can view the same. For the power frequency, there is a graph, and we can double click to zoom as well. The water level graph also the same. And if we wish to view the graph at the zoom out version, we can go back and click on the gauge again in order to view the full version of the graph. For the steam pressure, we can also view the graph of the steam pressure, and we can zoom in by double clicking. So now I would like to demonstrate the newly registered engineer, which is Thomas. The number is 01234567889. Now we will log out from the application and try with the newly registered engineer, which is Thomas. And if we didn't click the terms and condition check button, it will show that please agree to the terms and condition and enter a phone number. So our OTP is 238700. So if we enter a wrong OTP, the notification will show that there is an incorrect OTP. So if we forgot the OTP, we can go to the back end and check the OTP. So the generated OTP for this number is 238700. So let us try with the generated OTP. So the OTP is correct, and we can this engineer can only view the factory 2. This is because this engineer is only added to factory 2, so it can only view the factory 2. And the list of engineer is also provided only for factory 2. The function is same for the previous one, and we can also manage the setting by adjusting the minimum threshold. So if we would like to trigger the notification, we can always manipulate the value by manipulating the value of the threshold. So let's say if we change the value of water level to 70 and we save, and the notification will show that the water level reading fell outside the preset threshold. We can change the threshold value by just changing the water level value. So let's say we enter 20% and we click save. The value is sent to the database and the notification will not be triggered. So that is all for my presentation. Thank you for listening.